Hey, welcome to the numbers game. I'm Coach T, and in this tutorial, we'll be proving trig functions using trig identities. Let's get started. Trig identities are used to simplify trig expressions. Now, this can be super useful in a variety of math topics, including calculus. The best way to get familiar with the trig identities is to actually practice examples simplifying trig expressions. And so that's what we'll be doing in this tutorial, going through a few examples where we're simplifying trig expressions down to their simplest form using trig identities. Let's start off with our first example, simplifying sine squared of x minus 1 over cosine squared of x minus 1. Here we go. We'll start by simplifying our sine squared of x and cosine squared of x. Let's start by rewriting our numerator. Sine squared of x can be rewritten as 1 minus cosine square of x, and then we'll add our minus 1 back in. That minus 1 came from this one here. And we are able to rewrite sine squared of x as 1 minus cosine squared of x due to this trig identity. That is sine squared of x plus cosine squared of x is equal to 1. Note that if we were to subtract cosine squared of x from both sides of the equal sign, that would leave us with sine squared of x equals 1 minus cosine squared of x. We'll use this same trig identity to rewrite the denominator. In the denominator, we have cosine squared of x minus 1. And so we'll rewrite the denominator as 1 minus sine squared of x minus 1. Again, here all we did was replace cosine squared of x with 1 minus sine squared of x. And that is because of this trig identity. Simplifying this expression, in the numerator we have 1 minus 1. That'll give us 0, leaving us with negative cosine squared of x. In the denominator we had 1 minus 1 giving us 0, and this leaves us with just negative sine squared of x. For our final step, we'll simplify this expression down to cotangent squared of x. And that is by our trig identity, cosine of x over sine of x equals cotangent of x. We also had a negative factor in the numerator and a negative factor in the denominator, making our final expression positive. So in this example, we were able to find that sine squared of x minus 1 over cosine squared of x minus 1 is equal to cotangent squared of x. Now let's take a look at another example. We'll simplify sine raised to 4 of x minus cosine raised to 4 of x. We'll start by factoring out sine squared of x and cosine squared of x, so that'll leave us with sine squared of x plus cosine squared of x. Okay, and we're factoring out, and so we have sine squared of x minus cosine squared of x. Sine squared of x plus cosine squared of x equals 1. And so we can simplify this to 1 times sine squared of x minus cosine squared of x. And that is by our trig identity, sine squared of x plus cosine squared of x equals 1. So at this point, we're left with sine squared of x minus cosine squared of x. What we'll do next is rewrite cosine squared of x as 1 minus sine squared of x. And that is again because of our trig identity, sine squared of x plus cosine squared of x equals 1. Now let's get rid of the parentheses and rewrite this as sine squared of x minus 1 plus sine squared of x. Here we see we have a -1, and we have sine squared of x plus sine squared of x, giving us 2 sine squared of x. Now let's factor out a factor of -1 to give us -1 minus 2 sine squared of x, which leads us to our final answer of negative cosine 2x. And this is by the trig identity. 1 minus 2 sine squared of x equals cosine 2x. Thus, the expression that we were given, sine raised to 4 of x minus cosine raised to 4 of x, is simplified. Now let's take a look at our final example. Sine of x over 1 plus cosine of x plus 1 plus cosine of x over sine of x. And this is the expression that we'll be simplifying. Let's start by combining these two terms by finding a common denominator. We'll multiply the numerator and the denominator of this term by sine of x, and the numerator and denominator of this term by 1 plus cosine of x, leaving us with sine of x times sine of x over sine of x times 1 plus cosine x plus 1 plus cosine x times 1 plus cosine x over sine x times 1 plus cosine x. With a little bit of algebra, we can simplify this to sine squared of x plus 1 plus 2 cosine of x plus cosine squared of x all over sine of x times 1 plus cosine x. In our numerator, we see that we have sine squared of x plus cosine squared of x, and this can be simplified to 1. So let's simplify this a little further to 1 plus 1 plus 2 cosine of x over sine of x times 1 plus cosine of x. And again, that is because of our identity, our trig identity of sine squared of x, sine squared of x plus cosine squared of x equals 1. Now, take a moment to make sure that you have all of this stuff written down. I'm running out of space, and so I need to erase the board, and then we'll continue with simplifying this expression. All right, so we left off with 1 plus 1 plus 2 cosine of x over sine of x times 1 plus cosine x. Next step is pretty easy. We'll just add 1 plus 1. That gives us 2 plus 2 cosine of x in the numerator. We'll leave the denominator the same. Sine of x times 1 plus cosine of x. And then we'll factor out the 2. And that'll leave us with 1 plus cosine of x all over sine x times 1 plus cosine x. Here we see that we have a factor of 1 plus cosine of x in the numerator and denominator. And so the factor can then be canceled out, leaving us with 2 over sine of x. Let's rewrite this as 2 times 1 over sine of x, which is actually a trig identity. So our final answer is 2 cosecant of x. And this is by the trig identity. 1 over sine of x equals cosecant x. So we've been able to simplify the expression we were given down to its simplest form, that is 2 cosecant of x. So this example concludes this tutorial. This is how we use our trig identities to simplify trig expressions. As always, I'll leave you all with an example to do on your own. Simplify the expression cotangent of x times cosecant of x over tangent of negative x times sine of pi over 2 minus x. When you get your final simplified answer, drop it down in the comments below. If this tutorial clarified some things for you regarding trig identities and how to simplify trig expressions, give the video a thumbs up and also subscribe to the channel for more math tutorials.